Write in the chat.
Yes sir, we can.
Abdurrahman sir.
सर आपकी आवाज बिल्कुल सही आ रही है.
Okay, I'll start now. So today is my second talk, and topic assigned to me is principles of troubleshooting. This is the disclaimer as usual. Before I start my own talk, I want to give a recap of the course we have uh, conducted until now. Uh, the first talk was overview of DNR lab of LUMHS, and the talk was given by Dr. Fareen Maman and Dr. Faisal Imran. Then basic concepts and types of QC by Dr. Archinaz. Basis statistics was by Dr. Archinaz and Dr. Shabnam Khwaja. Choice of QC material was given by me last Friday, and difference between precision and accuracy was given by Dr. Hafsa Majid. Construction of LG chart by Dr. Shair Bano Imran. Laboratory errors by Dr. Sahar Iqbal. Principles of troubleshooting I'll be conducting today. So we are following a logical sequence. First, you heard about what are the types of QC, what are the basic statistics like mean and SD, which are you have to learn for running QC, and then the choice of QC material, which means the actual material which we run when we do the QC. So, uh, and then what is the difference between precision and accuracy? This is a basic concept and very important to be learned by all laboratory professionals. Then we also saw a very nice talk by Dr. Sherbano about construction of LJ chart. Then a scholarly talk by Dr. Sarik Bal about on laboratory errors. So when we have done the QC, we have started making the QC chart, LJ charts, and we have started recording the errors. Now we are here that we have learned how to find the errors and what are the different types of errors. Now the real uh, the times come of action. Action is troubleshooting. What do we mean by troubleshooting? We will discuss today. So, uh, principles of troubleshooting, specific learning outcome. So, at the end of this lecture, the students will be able to describe the principles of troubleshooting in a clinical laboratory. So, what is troubleshooting? Before showing you the slide, I will try to narrate it in simple words. Troubleshooting is actually, there are two words. Trouble means the actual problem, the error, and shooting means killing it or combating it or neutralizing it. यानी इसको मारना, trouble को खत्म करना, error को खत्म करना. So there are certain principles and certain procedures which we have to follow it. And today I'm going to talk for about 30-40 minutes about this. I'll I'll try to finish it by 10:30, including question answers and session, because today is Friday and we want to break at 10:30 exactly so that we can go on for our routines. So, troubleshooting includes occurrence management. Occurrence management is a term used for any system, not only in laboratory, but any system where occurrence means any error, any event, any mishap which has occurred in your system, in your organization, and management means how to manage it. Uh, so it includes such corrective and preventive actions. So troubleshooting doesn't include only the corrective action, but also the preventive actions. Planning as and you have to plan, uh, uh, not like this. When the trouble has occurred or error has come, then you start thinking what to do now. The SOPs should be ready. What to do when, what actions you have to take, and how to proceed about it. So it's very important that all SOPs should be ready for this. It includes minor laboratory issues not related to specific test. That means generalized laboratory management, generalized issues of temperature control, for example, of region storage, of training of the lab staff. So they are not specific to any test, but they are generalized laboratory issues. So if we do that, uh, we uh, we will we will be doing the troubleshooting beforehand. Investigations related to product failure out of specification results need to have appropriate processes clearly set out within the respective quality system. The procedures should be clearly set up. Associated investigation should move forward in a proactive and effective way. So, what are the criteria when we say that the system is out of control, and how now we have to do something? There is a need to do take action. When laboratory director or technical supervisor declares system out of control, when control limits when exceed predetermined limits, inappropriate interference in methods which is not correctable immediately, unacceptable imprecision, non-linearity, or interferences. If you are not aware of these terms, imprecision, non-linearity, or interference, don't worry. We will, inshallah, talk about this in a subsequent talk, probably next week. Individual patient results exceeds delta check against previous. This is another real-time problem. Uh, Probably tomorrow, somebody will be talking about delta check, and you will know delta check is not about controls. It is about the actual patient results, and it's very interesting. You must be present in that session. Now, as usual, I will take you to a small interactive session, and I will. There is a small interactive. Uh, just imagine that there is a dinner party going on of very rich people, very high socioeconomic circle. A very precious piece of diamond jewelry was stolen. The victim lady whose jewelry was stolen announced that there will be a blackout, and the thief should place jewelry on the dinner table. Otherwise, police will be called for thorough searching. The strategy was successful and jewelry was recovered. The party ended in a happy mood. Please give your comments regarding the best options. Culprit should have been caught by body search. The strategy adopted was appropriate. No action should have been taken. So only there are three options, not five. So what do you think is the best action to be taken in this situation? Uh, the culprit should have been caught, or the or it is okay. You have got the jewelry and no need of further. So A or B, just give your comments. Okay, very good. So very good thing is that you people are participating. Most majority says A, that culprit should have been caught after thorough checking, and there are few people who said it was adopted strategy was correct, that uh, mm, no need of finding any particular person. So let's see. Uh, no action should have been taken. Mr. Zain says no action should have been taken. Okay, let's see what is the best answer in my opinion. In my opinion, culprit should have been caught by body search. Why? What are my arguments in favor of this option? Why most of you and including myself go for this option? Because if you do not, if you skip the culprit and he's let loose, he will go to another party and he will be doing same thing in future. So it is necessary that we should find the culprit and give punishment to him so that he may not repeat it in the next time. So this is the same policy. Why I have given this example, that in quality control also we have to follow the same policy. Whenever an error is detected in a QC system, it is important to follow the principles of one at a time. We should, if all the steps are changed together, the real root cause of error will not be found. So we have to find the real root cause. What was actually wrong? So we have to catch the thief and not the stolen good. It is not enough that the uh, stolen good was found. It is not enough that you corrected the system without knowing what was the cause. You must know the cause, and then you should shoot it. So we call it one at a time principle. So one at a time principle says, first, it's not necessary that you may or follow this order, but it is a quite logical order. Repeat assays on control specimen using fresh aliquots of QC pool. Usually, what we do is, and most of the laboratories, when you reconstitute the lyophilized QC material with distilled water, usually 5 ml distilled water is added. A wise thing and a good practice is to make small aliquots of, let's say, 500 microliter or 200 microliter, and freeze them. So that on any particular day you um, take this aliquot and use as your QC material. So first of all, you may take a fresh another aliquot from your deep freezer or from your freezer, and use it and run it, reassay it. If the problem remains, then you repeat assay on control specimen using newly constituted. Then you uh, consider another vial of controls with usually 5 ml of water, distilled water, and reassay the controls. And if it doesn't work, then you assay different controls of similar known concentration to determine if original control material is at fault. For example, you are using controls of from manufacturer A, then you should use a control from manufacturer B and see whether problem persists or not. So then if it also problem still persists, then you look for the clots, region levels, mechanical faults, etc. Recalibrate the instrument for out of control and light, and reassay all controls. Install new bottle or new lot of one or all regions and recalibrate and reassay all. Perform periodic maintenance, recalibrate and reassay. So after each step, you have to reassay the controls until and unless the control is comes within the limits. So this is the main point of today's talk, that you should change one factor at one time. For example, aliquot of the controls, fresh controls, control from others manufacturers, then removing the clots, removing the mechanical faults, recalibrate the instruments, prepare new reagents. This is a suggested sequence, but you may not follow exactly like this. But usually the control should be changed first. So this is the main crux of today's talk. If I finish it here, it will be sufficient. This is the main message for carrying home today. That whenever you find an error, you should try to troubleshoot it by adopting a procedure of one at a time. Okay. When you have there are certain associated procedures also. We will discuss these procedures now. Call manufacturers to determine the cause, follow manufacturer instruction, and then reassay. If the problem still persists, then you call manufacturer, and he may be solving your. But there are, you please remember, the manufacturers usually have two types of engineers. If the firm is big and they are providing good backup service, there are engineers who are mechanical engineers who deal with the hardware of the instruments, and there are application engineers also. They are these application engineers. They are very much helpful in troubleshooting, because they would be setting the instrument factors, temperature, etc., and recalibrate the instrument, and it is now their responsibility to bring the controls within limits. Usually they say that if you're using third party control, they would say your control material is not good, then you have to kill this point by using controls from other manufacturers. If any of these responses result in acceptable QC data, only then patient results can be. It's very important. If the QC data comes within the control limits, only then patient results should be dished out. But all these procedures should be within 15 to 20 minutes and as early as possible. You have to react quickly. Of course, if you have to call the engineer, application engineer, then it will take some time. For example, in Hyderabad, you are in Hyderabad and you have to call the engineer from Karachi, then it may take a few hours. But barring that, at your end, there should not be delay. So if a problem persists, still persists, and then you should go back to the original data of your test. That means the linearity, accuracy, bias, precision, analytical sensitivity, and minimal detectable change. Now, these terminologies, these procedures, they are part of the method validation, and we will discuss, as I told you earlier, in a subsequent talk, probably next week. So if problem persists, we can go to that also. Determine whether testing system has changed by reassessing reference interval. You can also check the reference interval. Declare method of if all step everything is failed, and you couldn't find the solution. Troubleshooting is not successful. The engineer has also raised his hand, and then you should declare method out of control, and you should do something else. Final action: replacement of method or instrument with one that follows laboratory to meet its medical or proficiency goal. Then you should think of changing some other switching your method to some other manufacturer or instruments. This is a very important diagram, and it is called root cause analysis. Root cause analysis, you'll find it in literature, that this is a logical sequence of finding the root cause, one at a time, adopting one at a time principle. So these are various possibilities which can be found out and troubleshooted to make it correct. Now, for example, if you there was an error and you corrected it, and the your system is now okay, please now remember one more very important thing, and that is documentation of troubleshooting. Why documentation is important? Because it is important for the posterity. What it means for your future. For example, you are not on duty on some other day, and the same type of error occurs, then your colleague should be able to troubleshoot it in a shortest possible time. It is like those who are medical doctors, they know it very well. You must be knowing it during your house job or other clinical trainings, that if you give some injection or do some procedure on a patient, you have to document it right on the patient papers. So every test and every instrument should have papers, like patient papers. These papers are called usually logbooks. Uh, Logbook of the instruments and logbook of the parameter of the test. For example, there will be a logbook for your for your Selectra. There may be a logbook uh, for your hematology analyzer, but there should also be a logbook for hemoglobin. There should be a logbook for bilirubin, and on these logbook, you should write the date, the name of analyte, complete testing system, source of reagent, instrument, calibrators, controls, and what problem, and on when this problem occurred, how you resolved it, and who did the troubleshooting and what was the final action. It is not difficult. Once you make small logbooks for each test and each instrument, then it is very easy to carry out these entries. But remember this thing, these documentation are very important, not only for the smooth practice of your laboratory, but also for the accreditation, which will be also be a part of this course. Probably the last part of this course is laboratory accreditation. So it is very important in laboratory accreditation also. So, what procedure to follow during testing? Out of control condition can constitute a laboratory emergency. So, it is an emergency. Remember this. This can occur at 2 a.m. in the morning. So, you have to be ready for this. There should be SOPs. Your lab should have SOPs what to do in such situation. This is a laboratory emergency. Use suitable backup method. So, this is again a very very important tip which I want to give you personally. For especially for the routine test, the tests which are done on urgent basis, for example electrolytes, for example glucose, for example LFT, RFT, hemoglobin, TLC. For all such routine tests, you should have two systems in your lab. So I repeat, for routine tests which are usually done in urgent cases, you should have two systems. One should be backup, because at times you cannot do the troubleshooting, and it is impossible. That, as I said, it is 2 a.m. in the morning and no engineer is available. You can't do anything, and there are patients from A&D, from ICU. Patient samples have come, so you should be able to run it on a backup. Uh, Apparently, it seems that it will be a drainage of the funds, drainage of the resources, but I tell you, it pays a lot, because once you lose confidence in your clinical colleagues, then its cost is very high. So please remember, you must have a backup system. You or if you're a very small lab and you cannot afford a backup system, you should have an understanding with your reference laboratory, preferably an MOU, that you will send sample to them maybe at 2 a.m. And if it, now we come to those tests which are relatively less urgent, for example hormones, for example for example tumor markers, for example drug testing. So, and your system fails, and then you should have a contract with a reference laboratory or another laboratory in the neighborhood where you can send the sample. So temporarily discontinuing the test, should be the last option. But if you can't do anything, then this is the only solution. Laboratory policy should define how much time the technologies can spend troubleshooting a method before using alternate system. So that's why SOPs are very important. For each test on the logbook, you should it should be written, and this is the duty of director, usually a pathologist, maybe chemical pathologist, maybe hematologist, microbiologist. He or she should write these things on the logbook of the test, that laboratory technologists can spend only 30 minutes on troubleshooting, and if he or she fails, he or she should send the sample to, we should you start using alternate system. For example, your mainstay is an instrument. For example, let's say architect, you are doing mainly your tests on architect or cobas 6000, then and it fails and you can't do troubleshooting, the engineer cannot come, then you should have an alternate system like Selectra or Microlab where you can run this test. Now, I'll give you real life scenarios, questions, uh, in which we will discuss how to apply Westgard rules along with the troubleshooting. And I have taken these scenarios from Westgard website, and we will talk about this website also. Uh, I have not taken them as such. I have adopted them that I have made some changes in the scenarios. So, first scenario, which is actually the question two of today's talk, a lab runs three QC levels for TSH. That is level one, level two, and level three. Uh, Please hold on here. I told you that if low value and high value all are important, both are important in a test, then you should ideally run three levels. Level 1 for hypothyroidism, level 3 for hypothyroidism, and n- of course level 2 is for normal results, because mostly results are normal. The QC was very much within range, but on day 5 the QC for level 2 was suddenly 3 plus 3s, but QC 1 and 3 were within range. The results were dished out except those near QC2. On the next run, the QC for level 2 became minus 3s, but the QC1 and QC3 were within range. Which of the following actions you will take as a first step to catch the culprits? All three QC materials should be changed and reassessed. New calibration curve should be made. New lot of regions should be used. Omit using level 2 QC. QC level 2 should be changed and reassessed. So, what is your answer? Uh, Write your answer in the chat box so that I can see. Very good. I'm saying good because you are participating in it. Your participation really encourages me. Good, good, good. A lot of people are writing. Very good. And I'm very happy that most of you have written, well, all of you. I have not seen any other answer. All of you have written E. Yes, this is the best answer. QC level 2 should be changed and reassessed. So let's see why. Uh, 3S is a very important error. This is very important. Uh, uh, Out of Westgard rules, which you studied in the last lecture, 3S is very important because 3S is um, almost always a true true alert. It cannot be a false rejection. It is a true rejection. So in this lab, three levels were used for TSH to monitor patient results for hyper U and hypothyroidism, as I told earlier. The correct interpretation for the control procedure is to reject a run if any of the QCs exceed 3S limit. A control outside of 3S is not likely a false rejection. Something is definitely wrong. It is control material itself in this particular scenario, because it is quite obvious that level 1 and level 3 were okay, but only level 3 was repeatingly abnormal. But one thing was wrong in this particular scenario. The lab didn't do it nicely. That they should have done this on day 5. Why they waited for another for repeating the error on another day? The problem should have been identified on day 5 rather than waiting another day for to see the problem again. So another lesson is 3S should be killed on the same day. Not You should not wait, uh, be it on only one of the three controls. Probably the same vial of controls are being used for several days. There may be a problem in storage or contamination. Okay, okay. I hope you understand it. That if three controls, one is repeatingly abnormal, or only once is plus 3s has occurred, please do troubleshooting and don't wait for it to be repeated. Question 3. In a routine chemical pathology lab in urea assay, 2:2s rule has been violated on 20th January 2021. So, 2:2s rule has been violated on 20th January, which is a rule of rejection. You remember 2:2s? That means two consecutive values are above or below 2SD. Two consecutive values of the same control are either above or below the control values, 2SD values. Lab has taken appropriate troubleshooting and the reassert control results are now within 1 SD. The technologist in charge is a bit confused about including the value for calculation of mean and SD for the December 2020. Which of the following action she should take? I'm sorry, there is an error. It should be January 2021. It should be January 2021. So the technologist wants to know whether while she will calculate the mean and SD of January 21, whether she should include the corrected value or the values which came as error. This is a very important question. And when we see study Westgard rules, we must we usually stop there and don't go beyond. It is beyond study of the Westgard rules. For example, an error. I repeat the problem. An error has occurred, and you have corrected it. Now, which data you will include in the calculation of mean SD of the this month? It is a let me also revise your knowledge that you have to use running means and SDs. That means you will you will calculate mean and SD for January 21, and that you will use in February 21. So let's see the options. Which of the following actions she should take? Add both 2 to S values. B is add only the first 2 to S value. Add reassay control values. No value to be added for this date. Take average of 2 to S. So uh, what is your command? What are your comments? Let's see. Uh, a lot of answers in the chat. C, 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 C and D. But you can't have two. You have to be one. In best questions in any exam, you have to use only one option. C. Okay, I'll wait. C. Dr. Shumala Rees. C. Dr. Sidra. C. Dr. Kiran Qureshi. C. Takir Bhatt C. Sabah Mahar C. The Takir Bhatt B. Okay, this is your choice. B. Both. Both. A. Okay. Muhammad Ziaul Abdin. Both. Next. C. 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 Okay. Again, most of you have given the best answer. It is C. Add reassert control. This is, I think, the very important message of today. Don't add outliers in your calculation. When we will calculate the mean SD for the current month, you should not add the outliers. You should add the corrected values. Violations like 22S and 13S represent real problems, not false rejection. Inclusion of such outliers may result in broadening of the SD. This is the reason. If you will add the outliers, it will lead to the broadening of the SD, which is not acceptable. Tighter control values are also advised, not advised, it may result in false rejection in next month. So if now this is a question regarding the 1 2s value. One, if you do not add the 1 2s value as an error, and you do overdo it, and you reassay it and correct it, and then you add the corrected value, probably your SD will be to tighten, and that will give you the false rejection next month. So you may add 1 2s value, but not 2 2s or 1 3s value, because they are real outliers. If you could not understand this point, this is a very important subtle message in it, then you can ask me personally. Question 4. A laboratory technologist has posed a problem to the consultant pathologist that during daily practice in chemical pathology lab, if we get the 3-1S and troubleshoot it, recheck the analyzer condition, the calibration, the reagent, and the QC, the turnaround time of the urgent test become longer than the prescribed time. This will affect the treatment of the patient. What should be the solution of the problem? So you got the problem. The problem, what is the problem? Problem is if the test is urgent and you spend time in troubleshooting it, then the turnaround time will be increased, and the urgent the patient may suffer. So real problem. It's a very important real world problem. So see, let's see what are the options. Ignores 3-1S rules in urgent cases. Just change the QC material and run. Make a new control, assuming that the control was bad, and then run it. Troubleshooting should be done even if TAT is increased. Use an alternate system without QC results. You change the region and go to the other system, and without waiting for QC, you run it. Use sigma metrics for interpretation. What is sigma metrics we will touch upon in the subsequent parts. So what are your answers? Let's see. A, C, B, C, 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 E. There are some mixed answers. For example, uh, Hawa B, Shakil C, C A, Prayal Zafar A, Dr. Tia Begum, Arkam B A, Makar C, Absha. So this time there are mixed answers, which really fascinates me, because if the answers are mixed, that means uh, people are confused and there is a lot to be learned. There is a lot gap in knowledge. So it is the best answer is C. Troubleshooting should be done even if TAT is increased. Can't dish out a wrong result just to shorten the TAT. So this is a message. No compromise on QC. Can't give wrong urgent results. Uh, you, we should not compromise QC to reduce TAT. Turnaround time cannot be reduced on the cost of accurate results. In urgent cases, life-saving decisions are made on lab results. Uh, Now, urgent cases are more important because uh, the clinician, the treating physician is waiting for your result, and he or she has to make some life-saving decisions. So, accurate results are vital. Following quality insurance practices, yes, this is now important. That you should improve your laboratory practices. You should do quality assurances so that such situation should not occur. But if it occurs, then preference should be for the QC, not for the reducing the TAT. Remember this thing. Question 5. In a hematology lab, parameters such as MCH, MCHC, and RDW are consistently lying on one side of the mean. In LJ graphs, they are all on one side of the mean. More than 10, much more than 10, maybe 15, 20, they are on one side of the mean. They are violating the 10x rule, are lying at one level with no deviation. The instrument is calibrated correctly. The lab establishes its own mean and SD every month. This is very important. It doesn't follow a fixed mean SD. Every month, mean SD is changing. And I also should add that there are no complaints from the clinicians also of low hemoglobin. There's no such complaint of wrong tests. Lab staff are puzzled about application of 10x rules. What should be their modus operandi in this? Modus operandi mean what should they do? All such batches should be rejected as 10x is a rule of rejection. All Westergaard rules should be ignored for these hematology analyzers. Hematology analysis should be stopped immediately. In such situation, 10x rule can be ignored. Lab should not determine their own mean and SD every month. So now this is the real problem, that there is no compliant, nothing, but the 10x rule is being violated. What should they do? DAC, Dr. Kandharo, Amjad Iqbal D, Abdul Hafiz C, and Arshad Iqbal A, Anam Iftikhar A, Izaz Ahmad RBC Sakkar D, Rabil Qayyum A. Answers are less. Okay, B, A, C. Very much. Mixed answers. Faiza Akhtar A, D, A, Amara A, Afzal Shah A, Ira Iqbal C. So very nice mixture of answers. Again, a lot to be learned and seen and corrected. Batia Khan, A, C, very nice mixture of answer. This is very nice. No, the answer is D. In such situation, 10x rule can be ignored. You'll be a little bit surprised on this answer, but it is like this. It is now real world. My dear students, please remember, uh, studying Westgard rules is something else, and when you apply it on your lab, on your instruments in real time, it is a different story. So rules can be ignored. Sometimes you can ignore rule. If the mean is determined each month, it is adjusted to reflect current performance. If the test is performing with only minor variation, 10x violation should not matter. A rule like 13S is sufficient for QC material. So in such situation, just 13S will be sufficient, and you can ignore 10x. And this is the saying of Mr. Westgard, Dr. Westgard. Dr. Westgard is the person who devised the rules. So this is exactly his words. These are exactly his words. So I've written in inverted commas because these are his words. These are the words of the Dr. Westgard, who has devised the rules. He says, just because a rule exists doesn't mean it needs to be implemented. It is tempting to lock on 10x violations once you know about the 10x rule. But there are times to use the rule and there are times to not use the rule. Now, मैं इसको थोड़ा सा उर्दू में इस्तेमाल करूं. अब ये थोड़ी सी मार्फत की बात है, कि समझने की बात है बेटा. ये ये पढ़ना, बुक की नॉलेज, प्रैक्टिकल नॉलेज में फ़र्क है. आई एम सॉरी दोज हु डिडंट अंडरस्टैंड Urdu, or maybe there are some foreigners who cannot understand. What I said is, uh, there is a difference between theory and practice, and sometimes you have to see whether you have to apply 10x rule or not. And one very important thing also, uh, it is not part of today's talk, but we can arrange a talk on it, that Westgard has given some modified rules also, and but that requires a separate talk. Modified Westgard rules, but you can find them on the website. Okay, question number 6. A lab has fixed the lab limits based on total allowable error, taking one fourth the value of the total allowable error for the analyte as 1 SD. Now the lab has done some innovation. There was Aristotle sitting in the lab, and he or she maybe he or she uh, has done some innovation. What he or she has done is that they have fixed the limits. Uh, you know, I probably do not know the total. What is total liable error? Total liable error is given by international organization like CLIA about every test. For example, for glucose, the total liable error is 10%, and for most of the other tests, again, it is nearly 10%. But you have to see it. There is a chart for total liable error, and we will discuss in method validation. So what they have done is that they have divided the total liable error by 4, and that is the limit, control limit, for as 1 SD. So for 2 SD, they will multiply it by 2. What are your comments about? Now, these are comments. This is a cost-effective strategy. BQC strategy based on total average used in Westcard Sigma rules. Quite logical strategy, simple and safe strategy. Taking one fourth of total average is not evidence based. So, what are your answers? I know you do not know very much about this, but just logical, what logic says to you. Most of you have Dr. Kiran Qureshi E, Jawad Ali E, Jawadullah B, Itazaz E, Fatul E. Very nice. I'm really surprised to see the answers. Most of you have given E answer because it is logical. Taking you students are intelligent and you should be intelligent because sometimes if even if you do not know the content, the structure of the MCQ is such that you can find the best answer. So in this case also, taking one fourth of total average is not evidence based. It is not at all. You cannot do this. You cannot devise your own calculation, own formula, and use it. So not मैं आपको डराने नहीं लगा, लेकिन ये this is a very new thing, not very new. It came in 2018. Westgard Sigma rules for QC design and run size. Now, Dr. Westgard has given a new concept of QC rules, and it is based on sigma scale. Sigma scale is calculated on total allowable error minus percentage bias and divided by percentage CV. Uh, and on the basis of this sigma scale, we divide the labs on 6 sigma, 5 sigma, 4 sigma, and 3 sigma. 6 sigma are usually in which the size is 1000 per day sample size. I cannot go into details of this because it is out of the purview of today's talk, but we can have a separate talk on Westgard Sigma rules. But I tell you, this is very, very important. Anybody who is doing a post graduation in any laboratory science, you should know Westgard Sigma rules. I've heard this topic from two or three foreign speakers who visited Pakistan, and the whole talk of 1 hour was dedicated on this topic. So we will, inshallah, talk about it in detail. You can go through it in the website of Westgard. So today's take messages on violation of a Westgard rule. The cause of the failure should be sought without delay. Real culprit should be searched by changing control, region, calibrator, etc., adopting one at a time policy. All events should be properly documented. Outliers should not be added in the calculation of mean and SD. Uh, Before finishing my talk, there was a promise I made to you that I will tell you about the resources for QC. So very important source is the Westcard website. This you can Google it and you can go through this website and you will find everything about quality control, the Westgard rules. He is Mr. Website and his son is also part of this team, and you can find the Westgard rules, and it is almost free. Most of the things are free, and you can make your own login and y- your own password. Uh, there are some purchased parts of the this website also. For example, some calculators or the formulas, etc. There you have to spend money, but most of them are free. Inshallah, in my talk of method validation, I've adopted from this website, and I've made a very concise booklet also, and I'll give the PDF format of that booklet to you. So you can go. I tell you, can't learn quality control if you do not use this website. I've seen using these websites most of the foreigners, and there are very nice workshops in Dubai and other Middle East countries where Mr. James Westcott or Dr. James Westcott comes himself or his son comes. Another resource is the this book, Good Clinical Laboratory Practices in Pakistan. This was published by Pakistan Academy of Sciences in collaboration with the American Academy of Sciences. So Mr. This is Major General Amir Ikram. It is not Amir Ijaz. Please, this is not. This is Amir Ikram. So Mr. General Amir Ikram, Rita Ganther is from America, and Benjamin Russick also from America. So I was also part of the the authors, and I wrote 4 chapters in this book. Chapter on quality control, chapter on occurrence management, chapter on method validation. So uh, there is another 4th chapter also which you can't see. So this is very nice book, not only for quality control, for other laboratory practices. For example, the biosafety, for example, how to calculate the budgets, how to do laboratory administration, and a lot of things. So it is available from NIH Islamabad because General Amir Ikram is now commanding NIH. He is basically a microbiologist, and he is commanding NIH and very busy these days fighting corona. And this is the person, Mr. Adnan Bashir. You can contact him, and he will tell you the price and other details how to collect it. I think I have missed a digit in the phone, and I'll give you the exact number shortly. Okay. Then very nicely, this book has very recently, a few months ago, it has been translated in Urdu also. So you can see the Ishtarak, U.S. National Academies of Sciences, Engineering and Medicine, and Pakistan Academy of Sciences, and National Institute of Health. The same book in Urdu. This book is Chemical Pathology for the Beginners. This is actually a PSCP publication. I'm the main author of this book, and I have written a chapter on quality management. And my co-authors, reviewers, editors were Dr. Sir Iqbal, Dr. Hafsa Majid, Dr. Milia Zuberi, Dr. Nashin Bhatti, and Dr. Nuzar Fayaz. So yeah, you can get this book from me. Please contact me if you really want this book. If you have already have it, then it's okay. My this same book is now was also published in Europe by Lambert Press, and it is alhamdulillah available in Amazon also in $90. Its cost is not $90 in Pakistan. The This one you can get it only for 1,500 rupees, including the courier charges. Whereas in America, from Amazon, the price is nearly $89. So that is a blessing in Pakistan that you can get. It is exactly the same, only the cover is changed. Thank you very much. Uh, I, as I said, I will finish in half an hour. So in, we can have a question answer session of very short question answer, maybe 5 to 10 minutes only. You write your question in the chat box. If we calculate our own QC ranges, we observe that the range going tighter and tighter every month. How to correct this situation? The very important. Dr. Imdad Iqbal is a very important point. Yes, it does get tighter, but then your QC is improving. Don't worry about it. You should practice it. Thank you. Welcome, sound, Dr. Saida. Very nice. Any other question? And you are most welcome who are saying thank you. You are most welcome. Any other question? Most welcome, most welcome. Very soon, this will be available. This video recording will be available. Uh, Dow University of Health Sciences, they are doing wonderful job, and now they have sent the recordings also. I have not opened it, but only this morning they have sent the recording of the videos also. So you will get the videos too. Thank you for liking it. Thank you for participating in it. And I have no words of to say thank you to the people of people of Hyderabad for arranging this wonderful meeting. And with that, I think we should say goodbye. Let me see if there are any questions. So you can keep on asking questions uh, uh, privately also from on SMS or anything. Thank you very much. Analytical goal can be sigma level quality. Yes, yes. Uh, you can study Sigma metrics. Uh, it is not Six Sigma. Please remember, we are not talking of Six Sigma. We are talking of this is something else. Why did we accept 10x rule? Couldn't understand it. Dr. Faryal, let me explain to you. We accept when everything is well, when there are no complaints, clinical complaints, the body is having a running mean and SD, then you can ignore 10x. This is very important, but it needs expert. We will not accept it from a very junior person or novice, but a senior consultant can give an opinion on it. Please remember this thing. Thank you very much. I think we will say goodbye now. Okay, ji. Thank you, LUMS. Thank you, Dr. Abdur Rahman, for arranging this meeting. I know Dr. Ashi was busy somewhere else. And may we leave now, Dr. Abdur Rahman?
Yes, sir. We can leave.
Okay, thank you.
Allah Hafiz.
Allah Hafiz.